There's a new palace in the heavens. While the world watched the aging ISS, China quietly built Tiangong, a state-of-the-art outpost. How does this newcomer compare to the established giant? And what capabilities does it possess that could reshape space exploration? I am Jay, and you are watching Astrocium. Let's get to the topic. We observe two distinct orbital habitats: the veteran International Space Station, the ISS, and the relative newcomer, Tiangong, the Heavenly Palace. Two monumental achievements born of different circumstances, embodying different philosophies, yet sharing the same near-vacuum environment. Their parallel existence tells a fascinating story about human ambition, technological progress, and perhaps the future trajectory of our species beyond Earth. The International Space Station. Its story began on November 20th, 1998, with the launch of its first module, Zarya, a cornerstone laid not by one nation, but by an unprecedented partnership forged in the post-Cold War era. 15 countries resolved to pool their resources and expertise, constructing a shared laboratory in the sky. A truly remarkable symbol of global cooperation, wouldn't you agree? Its assembly was a masterpiece of orbital engineering, a complex ballet performed over years, module by module, truss by truss, delivered by rockets and space shuttles, meticulously pieced together by astronauts conducting daring spacewalks hundreds of kilometers above the Earth. The result? A sprawling structure, comparable in size to an American football field, housing laboratories from the US, Russia, Europe, Japan, and Canada. Within its pressurized volume, the largest of any spacecraft ever built, science has thrived for over 2 decades. Experiments in microgravity unlock secrets hidden from us on Earth, advancing materials, science, medicine, and our fundamental understanding of physics. The station provides an unparalleled platform for observing our own planet, monitoring its health, its climate, its changing landscapes. Crucially, it has been our primary laboratory for studying the long-term effects of spaceflight on the human body, essential knowledge if we ever hope to venture further, to Mars and beyond. A continuous human presence off-world, unbroken since the year 2000. Yet all structures, even orbital ones, have lifespans. The ISS, an engineering marvel of its time, is aging. Current plans aim for its controlled deorbit, a fiery but safe return through the atmosphere, sometime around 2030 or 2031. Its legacy, however, decades of research, international collaboration, and inspiring a generation, is indelible. It set a benchmark for what humanity could achieve together beyond Earth. But as one chapter prepares to close, another is well underway. Behold Tiangong, the Heavenly Palace, China's independent space station. Its journey into orbit began more recently, with the launch of the core module, Tianhe, on April 29, 2021. Completed with the docking of the Mengtian laboratory module in late October 2022, Tiangong represents a remarkable demonstration of national capability and technological prowess. Where the ISS was multinational from inception, Tiangong was conceived and built primarily by China, showcasing a different pathway to establishing a permanent human presence in orbit. Its design is modern, integrated, forming a distinct T shape against the cosmos. Though currently smaller than the ISS, it boasts state-of-the-art systems, efficient power generation, advanced life support, and its own sophisticated robotic arm capable of intricate tasks, including repositioning entire station modules. A design that perhaps benefits from lessons learned over the ISS's long operational life. Tiangong is a platform for ambitious science, space life sciences, microgravity fluid physics, astronomy, materials science, and Earth observation fill its research agenda. While initially a national project, China has expressed openness to international collaboration, inviting experiments and potentially astronauts from other nations under its framework. Its presence undeniably diversifies the landscape of low Earth orbit, offering alternative access as the ISS era winds down. This shift naturally prompts reflection on how future international space projects might be structured. Comparing these orbital titans reveals their distinct characters. The ISS, vast, sprawling, almost organic in its modular growth, reflecting its complex international origins. Tiangong, more compact, symmetrical, embodying a unified, modern design philosophy. Let's briefly examine some key technical distinctions. These differences aren't just numbers. They reflect design choices, technological eras, and mission objectives. The ISS's higher inclination allows observation over more of Earth's populated landmasses. Tiangong's lower inclination is optimal for launches from China. Even their orbits tell part of their story. Which set of characteristics seems better suited for the next phase of space exploration? It's a question worth pondering. Yet beyond the engineering marvels, these are profoundly human environments. Life aboard either station shares fundamental truths. The awe-inspiring spectacle of 16 sunrises and sunsets each day. The constant, vital hum of life support. The challenging, sometimes amusing adaptation to microgravity, where every action requires conscious thought. The isolation from Earth, balanced by the unique camaraderie forged among crewmates, sharing an extraordinary experience. Astronauts from all nations, aboard both stations, consistently report a cognitive shift, the overview effect, seeing Earth not as a map of borders, but as a single, interconnected, fragile biosphere. One has to wonder how this perspective, gained from these differing orbital platforms, might subtly influence global consciousness over time. Does seeing our world from afar inevitably foster a sense of unity? We are witnessing a significant transition in low Earth orbit. The ISS, the Grand Collaborative Experiment, prepares for its final act around 2030-2031. Simultaneously, Tiangong solidifies its position, potentially becoming the primary governmental space station for a period. China envisions its longevity, possibly expansion, and a role as an international platform on its terms. What does this evolving orbital ecosystem signify? Will space become more compartmentalized along national lines? Or will new hybrid models of cooperation emerge, perhaps involving the rapidly growing commercial space sector? The existence of multiple capable platforms could spur innovation through competition, yet the inherent risks and costs of spaceflight often necessitate collaboration. The data from Tiangong now joins the vast scientific legacy of the ISS, enriching humanity's collective knowledge. The orbital landscape is clearly changing. What kind of human presence do you envision in low Earth orbit 20 years from now? More stations, different types, new players? Two titans circling our globe. One, a seasoned veteran embodying decades of shared dreams and scientific discovery. The other, a potent symbol of national ambition and cutting-edge technology, charting a new course. Both stand as powerful testaments to human ingenuity, curiosity, and our innate drive to explore the unknown. They are our eyes in the sky, our laboratories on the edge of forever, reflecting our earthbound complexities and our shared aspirations. The story unfolding in low Earth orbit is dynamic, complex, and far from concluded. High above, the endeavor continues, and the lights aboard humanity's homes in the heavens remain brilliantly lit. If you like the topic of this video, hit a like and subscribe. You are welcome to share your thoughts in comments box about this video.